This is Apollo 5, the first all-up unmanned flight test for the lunar module, the spacecraft in which man will make his first landing on the moon, the final major piece of Apollo hardware to be tested. Now the lunar module, dubbed LM-1, sits in its protective technological cocoon atop the tested and proven Saturn 1B launch vehicle, waiting for the boost into the environment for which it was designed, space. It will not return to Earth, but will continue in a gradually decaying orbit until it re-enters and burns up. In the blockhouse at Cape Kennedy, the men have assembled to do the job. From Marshall Space Flight Center, from the Kennedy Space Center, and from the Manned Spacecraft Center, they have come to get the mission into orbit.
RTC, will use Site Select, Guido, GNC, and ECOM to Mila.
In Mission Control in Houston, flight controllers wait to take over command of the mission as soon as it lifts off the pad. Among these men are 4 who watch with special interest. Astronauts Jim McDivitt and Rusty Schweikert, who are scheduled to fly the first manned lunar module. And in a support room next to the control room, astronauts Frank Borman and Bill Anders, who will fly the lunar module on its rehearsal of the first manned lunar mission.
Go flight. GNC.
Go flight.
Procedures.
Go flight.
AFD.
Go.
Network.
Go flight.
Computer soup.
Go flight.
RTC, you on AFD conference.
RTC's on the FD conference.
Roger. Best of luck.
Number 2 is go. Okay, go ahead and reload.
All flight controllers preconditioned for attachment 2 of the internal count.
So men wait in tracking stations around the world for the flight of lunar module number 1. For it is their information that will tell us whether it is safe for man. But what is this craft called the lunar module?
LM is a vehicle that has been designed for a particular job, and that job is to land on the lunar surface. It doesn't look like an airplane or a spacecraft in the old sense. It's not smooth. It's very thin-skinned, has a descent propulsion stage, a large descent engine which will be used to land the vehicle on the lunar surface in a manner very similar to that of a helicopter, except that instead of using blades for a lift, we'll be using a rocket propulsion engine. And the upper stage, the cabin and ascent engine stage, will be used to lift off from the lunar surface and make the subsequent rendezvous with the command and service module.
So the LM is really the taxi that provides the transportation between the orbiting command module and the lunar surface.
The lunar module is a unique engineering concept. Designed and built on Earth, it is out of place on its native planet. The airless surface of the moon, the empty reaches of space, this is where it belongs. The comfortable pull of Earth's gravity, the protective, life-giving atmosphere, these, to the lunar module, nicknamed LEM, are the hostile elements. Its engines cannot lift its own weight against the pull of the Earth. If it could fly on Earth, the aerodynamic forces of the atmosphere would tear it apart. So how do you test the lunar module before it flies in space? You test its engines in the man-made vacuum of an engine test stand. Its operating systems in gigantic vacuum chambers. You tumble it on stands in engineering laboratories. But the real test is when it flies.
Roger, I am in flight control. Final status check, booster.
Go.
Retro.
Go.
FIDO. Go. Guidance.
Go.
ECOM.
Go.
While the primary instructions for the mission are carried on board the LEM, the men on Earth in mission control can take over and fly it if necessary. But why all these elaborate precautions and details in an unmanned flight?
Unmanned LEM-1 mission is one of the key missions in the entire lunar landing program. You must remember that the LEM is every bit as important as a spacecraft as the command module, the Gemini, or the Mercury was, and this is the first flight of the vehicle. Naturally, we'll all be looking at it with very, very keen interest.
Flight CVTS Flag 2, verify your go for launch.
Roger, we are go for launch. Okay, all flight controllers, let's play it cool.
Launch sequence start.
15, 14, 13, 12, 11, 10, 7, 6, 5, 4, 3.
Ignition detected.
Transmit 5 enter.
Clock start. 5 enter. Thrust okay.
Affirmative. Program 11.
Okay, TLK P11.
Roll pitch start.
Roll and pitch. Go on IP. Go IP. Stand by for nose.
The launch and insertion into Earth orbit are on the nose.
Cutoff plus 50.
Roger, cutoff plus 50.
The aerodynamic shroud is jettisoned.
Roger, nose cap jet.
Now the next critical step, the opening of the protective metallic petals and the separation of Lunar Module 1 from its cocoon.
RTC booster, transmitting slot deploy.
Roger. We are transmitting slot deploy.
Okay, all flight controllers, we have slot deploy A and B relay indications, no physical monitor indication.
Everything is nominal.
We get a go for separation.
On schedule, the reaction control engines of Lunar Module 1 pull it free of its protective cocoon. The space butterfly rests its wings before it flies. Now begins the long coast preparatory to the first firing of the descent engine. While the LEM coasts, tracking stations pinpoint its position and determine its orbit with accuracy. In Houston Mission Control, engineers are testing the many systems on board.
The LEM, I think, is like a big line of dominoes, every one of which has an effect upon the one it's associated with. And nothing can occur in one that doesn't somehow affect the others or the total mission.
So LEM 1 coasts on, guided by its onboard programmer, seen only by the radar eyes of the tracking network, watched over by the men in Mission Control.
We will not pulse the engine. The maneuver is go at this time based on the onboard.
Roger, Houston.
On.
Roger, Houston is go for the burn.
Request.
The lunar module nears the Australian coast. The Carnarvon tracking station takes command. The time is nearing for the first burn of the descent engine, the first rocket engine designed to be throttled, a necessary feature for a lunar landing. This will be its first burn in space.
Mark. Predicted ignition.
Dips on.
Dips on.
10%.
10%.
Tone.
We got a pings caution. Program caution.
Roger.
Dips off.
But something goes wrong. Instead of the full 38-second burn, the engine shuts down after only 4 seconds. An early look at the data indicates the onboard computer did not allow for the tolerances and errors within this most complex of all missions. It shut down the descent engine when it sensed an error of less than 1.5 seconds, and computers don't argue.
Capability of a crew, I think, is very significant in that you can change your mind in flight. You don't have to be restricted by the rather narrow capabilities of any pre-programmed mission.
Faced with the unexpected, the computer made the only decision it could, and it was the wrong one. Now the success of the mission rests squarely on the team in Mission Control and in the tracking stations. The nominal plan is out the window. On communications lines all over the world, the alternates are discussed. But the final word must come from Flight Director Gene Kranz.
I guess our best plan here, and I think the way we're going to go, is alternate Charlie. Go ahead. In the attitude you've got. Go ahead. At 6:15 elapsed. Go ahead. Okay.
The long throttle burn of the descent engine would be cut to 2 minutes and occur during its pass over the United States. Then the descent engine would go to 100% thrust preparatory for the biggest test of the mission, fire in the hole.